Volcanoes. Let's get this title down. Have a go at those do now questions. Unpause when you're ready. So the name volcano is comes from the Roman god of fire, Vulcan. Yes, there are volcanoes in East Africa. We're going to talk about why. So we're looking at the country Kenya. A volcano is an opening in the Earth's crust through which magma, ash and gas erupt. So here are our learning objectives. So we're going to describe the difference between magma and lava, describe the location of volcanoes around the world, explain how the temperature of lava affects the shape of the volcano formed. Our key words: active, dormant, viscosity, magma and lava. Rock under the Earth's surface is so hot that it melts. This melted rock is called magma. Heat rises, so the magma moves towards the Earth's surface. So that's a good key point there. When you go through the slides later, click on that image. There's a fantastic video which will help you with the key points. Rocks under volcanoes are very hot. They melt to make magma. Magma collects under and inside volcanoes in magma chambers. So if we look there, we've got the magma that's being built up. Now there's two main reasons why it's getting built up. So either at the crust boundaries we've got a destructive process going on and we're getting a build up of magma because part of the crust is melting, or the crusts are being moving away from each other. We call that a constructive boundary, and the magma is being pushed up in that way. So those are the two main ways. We're going to go into those in greater detail. So that's why we get magma chambers, and that's why we get an increase in pressure at the magma chamber. So let's go through this again. Eruption: pressure built up in magma chambers, and we'll talk about why. So that magma, in order for the pressure to build up, we need there to be an increase in magma. That could be one reason why we get a build up in pressure, or the chamber is being squeezed together. Okay, so that could quite possibly happen, especially if boundaries are overlapping. So we get an increase in pressure build up in magma chamber. The pressure forces magma out of the volcano along with gases, ash and bigger pieces of solid rock. So we'll talk about that pressure build up in more detail later on. So at the surface it erupts to form lava flows and ash deposit. Erupting magma is called lava. So once the magma has erupted and we see it on the surface, that's when it's called lava. Here's a nice diagram. Pause, take any notes and unpause when you're ready. So we've got a cross section of a volcano. There's our eruption, so that's the spill out of gases and ash. We've got the main vent where the magma's being pushed up. We've got the layers of lava and ash, and we've got the magma chamber there at the bottom, crater at the top. So in terms of where the volcanoes are located, so we learnt about the Earth's crust, and we know that the crust is like a big jigsaw. There are gaps in the Earth's crust. It's made up of what we call plate tectonics. So different plates of crust are joined together to make the Earth's crust. So if you look at the image at the bottom left, that's the best idea of best view of what the crust looks like. And at these boundaries, well, that's where the plates might overlap or they might be pulled apart, and in both of those situations you get the forming of a volcano. The Pacific Ring of Fire is an area of frequent earthquakes and volcanic eruptions encircling the basin of the Pacific Ocean. The Ring of Fire has 452 volcanoes and is home to over 50% of the world's active and dormant volcanoes. 90% of the world's earthquakes and 81% of the world's largest earthquakes occur along the Ring of Fire. So we've got plate boundaries there, and because of those plate boundaries we're getting volcanic activity along with earthquakes. So as well as the danger from the hot lava, there are other dangers that come with a volcano erupting. So these could trigger tsunamis, flash floods, earthquakes, mud flows, rock falls, and there are plenty more natural disasters that come through the eruption of a volcano. So let's look at these. So pause, have a think about which order these events would happen in. When you're ready, unpause. Okay, so let's just go from the beginning. The Earth is made up of 4 main layers. These are the crust, mantle, outer core and inner core. So we've got the crust on the outside, and the crust is made up of plates that look a bit like a jigsaw. The plates that make up the Earth's crust collide, so we've got all this activity going on with the plates, yeah, at the boundaries. And when those crusts collide, the magma is squeezed through the plates, and volcano causing an eruption. The magma flows between the crust and mantle of the Earth. The lava flows around the local area. So some people live near a volcano. Make a table to write the advantage and disadvantage of living near a volcano. So I'm just, because you've got lots of time constraints on the other subjects, let's just go through these. So advantages: can be safe for many years. Soil is very good for farming. Yes, so the soil that's formed from volcanic eruptions is very fertile. Mining tin, silver, gold, copper and even diamonds in volcanic rocks. Use heat energy from volcanoes. And tourism. Yes, people very interested to see a volcano, for example Mount Vesuvius in Napoli. Disadvantages: lava and earthquakes can kill people. Ash and dust can cause breathing problems, absolutely. Kills farm animals, harms crops and water. So those are the disadvantages. So these are the two ways that we get a volcano forming. We've got what's called constructive plate boundaries. So when the boundaries at the plate are widening because the plates are moving apart, we get magma being pushed through and new rock forming at the top. So that happens there's a classic one. It happens at the Atlantic Ridge, at the bottom of the Atlantic Ocean. We've got what's called a constructive plate boundary, and that's where magma is being pushed through and new rock is being made. So another example we've got here, Iceland. We've also got a destructive plate boundary. So when the plates overlap, so let's look at number 1. The plates are moving towards each other. Number 2, one plate falls downwards. Number 3, magma rises to feed the volcano. So as that plate is forced downwards, 2 things are going on there. So one, that plate, that crust that's moved downwards, going towards a hot region, and is melting. So it's increasing the amount of magma in our magma chamber. But you've got to remember also that magma chamber, even though we're getting an increase of magma inside of it, it's being squashed as well, because we've got the additional plate being pushed through as well. So those great forces at play are what eventually cause that volcano to erupt and that magma to be pushed through. Okay, and there's number 4. So layers of old lava and ash building up on the top. We've got the fresh lava flowing through. We've also got these side vents, so the mini eruptions happening on the side of the volcano, and there's our main vent at the bottom, where our pool of magma initiates from. So Villarrica in Chile is an example of that. So types of volcanoes and shapes of volcanoes. There are 3 types of volcanoes. Active eruptions can be any time and often. Dormant has been a while since it has erupted but could at any time. Extinct, meaning it hasn't erupted in a very long time, so it probably won't ever again. Mount Fuji in Japan is a dormant volcano. So how many different types of volcano are there? The type of magma in the earth creates 4 types of volcano: shield volcanoes, composite volcanoes, cinder volcanoes, lava domes. This cinder cone in western Nicaragua has a name that means black hill. Shield volcano, flat. So volcanoes that build up from many slow, steady flows of hot lava are called shield volcanoes. If the magma is running, the gas can escape easily and there will not be an explosion. The magma just comes out of the mountain and flows down the sides. Shield volcanoes are a type of volcano given their name for their broad, gently sloping profile which looks like a warrior's shield. Examples include the volcanoes in Hawaii and Mount Etna. Composite volcano, tall and thin. If the magma is thick and sticky like honey and gas cannot escape, so it builds up and up until it explodes, sending out huge clouds of burning rock and gas. Composite volcanoes are steep-sided volcanoes composed of many layers of volcanic rock, usually made from thick sticky lava, ash and rock debris. Composite volcanoes are also known as stratovolcanoes. Examples including Mount Fuji in Japan, Mount Cotopaxi in Ecuador, Mount Shasta and Lázan in California, Mount Hood in Oregon, Mount St. Helens and Mount Rainier in Washington, and Mount Etna in Italy. Cinder volcanoes. Cinder volcanoes are circular or oval cones built from erupting lava that breaks into small pieces as it shoots into the air. As small pieces fall back to the ground, they cool and form cinders around the vent. Lava domes. Lava domes are formed when erupting lava is too thick to flow and makes a steep-sided mound as the lava piles up near the volcanic vent. The eruption of Mount St. Helens in 1980 was caused in part by a lava dome shifting to allow explosive gas and steam to escape from inside the mountain. Okay, we've got some true or false here. Okay, let's have a read through this, and then think about whether it's true or false. So pause, have a go, and then when you're ready, unpause. Number 1, the dormant volcano is sleeping and may erupt again. False. We don't believe it's going to erupt again. Lava is expelled from the volcano when it is active. This turns into magma which when cooled makes up a layer of rock on the outside of the volcano. True. The temperature of the lava can range from 700 degrees Celsius to about 1600 degrees Celsius. The temperature depends on the depth of the magma. True. Volcanoes often produce spectacular scenery and therefore provide tourism. Many people have travelled to areas of volcanic activity for many centuries for activities as diverse as sightseeing, mountaineering, volcano boarding, camping, as well as hot air balloon rides over the volcanic landforms. True. The exact number of volcanoes is unknown as it depends on the exact definition of a volcano. During the past 10,000 years there are about 1,500 volcanoes on land that have been active, but the even larger number of submarine volcanoes is unknown. There are about 600 volcanoes that have known eruptions during recorded history. That is true.